At 60, this is 30. It's a special right triangle. This is 1/2 x. Across from 30 is the small side. Across from 60 is the small side times the square root of 3. So it's the square root of 3 over 2x. So the area of this triangle is 1/2 base times height. Base, height. So the area simplified would be square root of 3 over 4x squared.
That's what Tom said.
I was on the right track.
I got that right started.
Oh no, he said.
That's on the right track.
I didn't hear it. Sorry.
I didn't have it written down.
Okay, so that is just the generic area of an equilateral triangle given its one of its sides. Okay, so we need to apply that to this problem. So my new a of x, I'll be consistent with the color, is something squared. What is my something? Oh, that was. It's not something squared. That was the last problem. What's my a of x here? What is the area of the green triangle?
Square root of 3 over 4x squared.
It's the square root of 3 over 4 something squared. What's my x though?
7.
This is my base.
2y.
It's 2y, remember? So it's 2 square root of 49 minus x squared.
Simplify 2, 4, 49.
Did I lose ya?
No.
Yeah.
Is it always going to be like that?
Is it always going to be what?
We chose the same.
Is it going to be 2y? Good question. No. You're going to have semicircles, you're going to have all sorts of different shapes on the bottom. In this problem, it's always going to be.
I'm still not understanding how to figure out that it's 2y.
This is y,
How do you Yeah.
because right here makes maybe more sense. Do you agree that this distance right here is y? Which is also this, right? So maybe if in terms of x, you know that height is square root of 49 minus x squared, and it's just twice as big, so it's 2 of those.
Okay.
That makes sense?
Yeah, that makes sense.
Okay. Okay, and then you could clean that up, integrate it from -7 to 7. Okay, that's just 2 examples of the cross-section method. In your assignment, your first couple problems only ask you to find a of x. You're not even finding the volume. They'll say, give me an area function represented by, and then they'll tell you what the parameters are. Okay, you're not actually finding the volume right away. Questions so far? That's only one of them. We got 3 more.
We get the applause.
Yeah, we should. Background applause. All right, let's start revolving.
Which method is?
You don't have to graph in 3D for anything else except for this probably. All right, so let's say I have graph y equals 1/2 x. Let's graph y equals 0 and x equals 3. Okay, so we've done area in 7.2. We know how to represent that area. It's just top minus the bottom, right? So in this case, we are revolving it around the x-axis. So if I revolve just this area around an axis, what kind of shape am I going to get?
A cone.
A solid cone, right? So it's going to look like okay, so the disk method is what we would use. Okay, it is pi r squared. Why is it pi r squared? What does pi r squared represent?
Circle.
Area of a circle. Good. So each of these cross sections is a circle. Okay, so we haven't done this before. But we need to find the radius of my circle. Already I know
We did it. Didn't we do it with rams, Mr. Winkler?
Something like this, yeah.
we didn't revolve anything.
I know
We
it
did
was
one
like
problem
slightly-
where I kind of showed it. The sine x one.
Yeah.
What's my radius here?
1/2 x.
1/2 x. We're done. At least setting up our integral. We're From where to where? What are my boundaries of integration?
0 to 3.
0 to 3.
0 to 3. Okay, so when do you integrate with respect to x? You integrate with respect to x for the disk method, for the washer method, if you have a horizontal axis of revolution. Okay? So your axis of revolution might actually be up here or down here. If it is horizontal, you will always integrate with respect to x for the disk in the washer method. Okay? That changes on Monday for the shell method. Okay? So I knew we were integrating with respect to x. So if we're integrating with respect to x, we need, for the boundaries, we have to start at the beginning and the end. So left and the right, and that's where we get the 0 and 3. Jake?
I have 2 questions. Will they always tell you what you're going to revolve it around?
Yes?
And in that problem, what if they said to revolve it around y equals 1/2x? How would that differ? Or would it not?
We would, in this class, we will never revolve around anything but a vertical or horizontal line.
Okay.
Good question.
Revolve around
I
the
was just
Z
wondering if you had my log of hours for the secret project.
I probably do.
Okay.